The mesh generation step is automated in the linear structural validation application. Therefore, a mesh is generated automatically when you hit the Simulate button, and it is for this reason that the option is not provided in the Simulation Assistant. However, the user has the option to refine and update the mesh before running the simulation, in order to improve the accuracy of the results. This is shown next. To change the mesh settings, go to the Mesh tab in the action bar, and click on Mesh Specifications. The Mesh Specifications window opens. The options at the top allow you to refine the mesh. Here we are interested in refining the mesh. Mesh control is an important factor in determining the accuracy of the results. A coarse mesh implies reduced computation time and resources. However, the results might not be sufficiently accurate. A fine mesh, on the other hand, implies longer computation time and resources, but improved accuracy of the results. Mesh refinement is especially essential in regions of high stress concentrations, such as near regions of contact, or sharp features such as corners, etc. To refine the mesh, select the Part Body option under the Product Structure tree, for the first component. The selected component is highlighted in the graphics window. Click on the Edit Mesh Specifications option. In the Edit Mesh Specifications window, enter 2 mm, under Element Size. The minimum number of elements around a circle defines how the small features in the geometry, such as holes, will be meshed. This will be left to the default value. Click OK. Repeat the process for the second component. Click OK to close the Mesh Specifications window. Click Yes to confirm mesh upgrade and generate mesh. The mesh display can be shown or hidden by using the Visibility Manager. To hide the mesh, go to the Display tab in the action bar and click on the Visibility Manager. Select the Hide All FE Models option in the Visibility Manager window to hide the mesh. The Show option can be used to view the mesh. Close the Visibility Manager. The simulation is now ready to run. Select the Simulate option under the Simulate section of the Assistant. Select Local Interactive, under the Location option in the simulation window. Select Tokens, under the License option. Accept the other default settings, and click OK. The simulation dialog box appears, showing the status of the simulation. Close the Simulation Status window when the simulation is complete. Use the Plot menu to select and view the von Mises stress distribution in the assembly. Observe that the maximum stress in the assembly occurs near the fixed region of the larger ring. To have a better view of this maximum stress, the user can adjust the maximum value for the legend. To do this, double-click the legend. Enter 600 under max, and press Enter. Now the regions of maximum stress are clearly visible in red color. Notice that the stresses are also higher in the region of contact between the two rings. Now let's move on to the displacement results. Select Displacement from the Plot window drop-down. Notice that the displacement is 0 in the fixed region of the larger ring, as expected. The smaller ring, which attaches to the bracket, has the maximum displacement due to the action of the pressure loading applied. This loading pulls the larger ring, hence we observe increased displacement in regions of the larger ring, shown in green and red. To save your simulation setup and results, use the menu to select Share and click on Save. This saves your simulation to the collaborative space on the 3D Experience platform.